what we're looking, what we mean when we say a thunderstorm is severe. As we mentioned in the previous section, with the different different stages of a thunderstorm, we're most concerned about the mature and dissipating stages when we are talking about severe weather. So what do we mean when we say severe thunderstorms? In order to be severe, a thunderstorm has to contain one or more of the following: winds of 58 miles per hour or higher. Now that criteria sounds a little bit arbitrary, and to a certain extent it is. It relates to 50 nautical miles per hour or 50 knots. But that is also the 55 to 60 mile per hour range is also where we start to see more significant tree damage and potential damage to outbuildings. Below that 55 to 60 mile per hour threshold, you can see some minor tree damage, and you can see trampolines and light outdoor furniture blown around. But in general, below that threshold, you're not going to see a lot of damage. So that's the reason we set the criteria where it is. And we'll talk more about that in just a minute. Hail of 1 inch in diameter or about the size of a quarter or larger. And then obviously anytime a storm produces a tornado, that is considered severe. Now, all of this criteria, one point is that you see no mention of lightning. Any thunderstorm, by definition, has the potential to be deadly because, by definition, it has lightning. But that is not a criterion for a severe thunderstorm. And the reason is we are constantly trying to walk a line in not warning and not overwarning people so they start to ignore severe thunderstorms, but at the same time warn for truly hazardous weather. So for that reason, these are the criterion for severe thunderstorms. So we're going to go through each of the three criteria that make a thunderstorm severe, starting off with tornadoes. This picture here is actually one of a local example. This is from La Plata, Maryland. And we'll talk more about why we don't have as many local examples in this presentation. What exactly is a tornado? A tornado is this is a definition straight from the Glossary of Meteorology: violently rotating column of air that is connected both to the thunderstorm cloud and is in contact with the ground. So three key things there. It has to be rotating quickly. It has to be connected both to a thunderstorm cloud as well as connected to the ground. So a funnel cloud rotating rapidly that is connected to a thunderstorm is just that. It is a funnel cloud. It is not considered a tornado. I actually had a professor that would get quite annoyed if people said tornado on the ground, because by definition that is redundant. By definition, a tornado is in contact with the ground. One thing to note about this, though, is that while the rotation may be in contact with the ground, that condensation funnel, which is that clearly defined condensation funnel, you may not be able to see that clearly all the way to the ground. You may see a condensation funnel or a funnel cloud that ends slightly above the ground, but if you look on the ground, you may see a whirl of debris. That would still be a tornado. So you may not have that funnel cloud extending all the way to the ground, but as long as the rotation extends all the way to the ground. That is a tornado. Now, you whirlwinds or dust devils that are not connected to a thunderstorm, those are not considered tornadoes, because again, they have to be connected to a thunderstorm. In our region, it is most common to see these in the spring and summer months, but they can occur any time of year. In fact, I'm recording this presentation in early November of 2019, and we just had one tornado on Halloween night just a few days ago. We'll talk more in just a few slides about the rating scale that we have for tornadoes. They're rated on a scale of 0 to 5. And for our region, the vast majority are on the weaker side of that rating scale. This is not an example from locally. This is an example, as you might imagine, looking at the background there, from the high plains. And I mentioned before, we'll talk briefly about why a lot of this presentation has examples that aren't local, and that's the reason is that it's hard to oftentimes in our area, the funnel cloud will be hard to see because it will be either wrapped in heavy rain, and so very difficult to see, or just because of the land use around here with lots of trees, lots of elevation changes, you may not be able to see the funnel cloud, or may not be able to see much of the area below the cloud base. So a lot of the examples you'll see here, just to give you an idea of what a tornado looks like, but again, they're probably not going to be as easy to see in this part of the country. It's very rare that you have a well-defined, you can clearly see a tornado in our area. This one is also from the high plains, but you can see it's a little bit harder to see because it is in front of a area of heavy rain, so it kind of blends in with the background behind it. Now here is one of the better well-defined examples from our local area. This is from New Jersey, back in 2001. So what are the ingredients you need for tornadoes? Well, you need the same ingredients that you need for thunderstorms. The three main ingredients we talked about before: moisture, instability, and lift. And you can see some of that represented there. But then you'll need one more factor for tornado threat, and that is wind shear. And wind shear is a fancy way of saying that the wind is blowing in different directions at different levels in the atmosphere. Now, in order to see tornadoes, a wind shear has to be a very specific kind of wind shear, because typically, vast majority of the time, rotation happens in a counterclockwise direction in the northern hemisphere. So I want to talk too about some other clouds that are often talked about in association with tornadoes, but not necessarily tornadoes. Some of these can be harbingers of potential tornado development, and some are harmless, and we'll talk about that. First, talking about a wall cloud. This is a local lowering of the cloud base. And if you see in the example here on the right, you can see for the most part the cloud base is above the electrical wires there, but you see right in the center there is a part of the cloud base that is lower. It is a part of the updraft, so this is not going to be a part of the downdraft. Remember when we were talking about the updraft and downdraft, the downdraft really doesn't have a well-defined cloud base, or if it does, it looks pretty streaky. The wall cloud is always going to be a part of the updraft. Now, a lot of storms have wall clouds, and not a lot of storms produce tornadoes. So it's important to note that just because you see a wall cloud does not mean that the storm is tornadic. Some warning signs that you can see is if that wall cloud is rapidly rotating, and if it is persistent, then that can be a sign that the storm could become tornadic. And if you do see one of those warning signs, then that would be a good time to report a wall cloud. But just seeing a wall cloud on its own, again, does not necessarily mean that the storm is tornadic or could become tornadic. A funnel cloud, we talked briefly about this before. Again, this is very similar to a tornado. The only difference is that it is not connected to the ground. If you do see a funnel cloud, do report it. Obviously, it won't take much if we already have a funnel cloud to have that transition to become a tornado. So we appreciate if you have a report of a funnel cloud, appreciate that. It again develops in the updraft of the storm, like the wall cloud and tornadoes. This is all happening in the updraft portion of the storm, not in the downdraft portion of the storm. Here is a very well-defined example. Again, it's not common to see such a well-defined funnel cloud here. This is from the high plains. A waterspout is very similar to a tornado. The only difference is instead of being in contact with ground, it is in the rotation is in contact with water. So it is not uncommon to have these over our larger bodies of water, Chesapeake Bay, Delaware Bay, and the ocean. In this case, this is looking out from Belmar, New Jersey. So a local example here. Finally, scud clouds. Also known as scary-looking clouds. These can be quite scary-looking and can resemble some of the other features that we just talked about, but are in and of themselves harmless. So, in the example that you see there on the right, you see two features, one kind of in the left side of the picture here, and one more in the center. Both of which, if you were just taking a quick glance, and might make you do a double take, because in both cases they kind of have the look of a funnel cloud. But in this case, neither one of these is a funnel cloud, neither one of these is a wall cloud. And the key to distinguish the difference is, number one, know where you are in the storm. If you are in the updraft area. In this case, we are in the updraft area. Number two, look for rotation. Again, that is going to be the key in knowing if a storm is about to become tornadic, is if you see rotation in the wall cloud. And a key in oftentimes in distinguishing some of these more ominous looking scud clouds from a funnel cloud is looking to see if there is rotation. In the case of this picture, there was no rotation here. And the case of the large feature on the left-hand side, that is actually, the storm is moving over a large lake, and that was relatively warm. So as a result, there was water from the lake was condensing and moving up into the updraft. So it's very scary looking, but in fact, this was a harmless case here. Here's another example. Again, some clouds that would make you do a double take, but in this case, you can see how the sky looks a little darker behind these clouds. That is actually, you're getting into the downdraft section of the cloud. So again, It's kind of scary looking clouds, but in and of themselves, they are harmless. So now we've gone through all sorts of different cloud features, and I wanted to give you another example. This is a local example and a relatively recent example. So I'm going to give you just a second to think, what is this feature? Kind of in the center here of this picture. Based on all of the cloud features we've talked about, wall cloud, funnel cloud, tornado, scud cloud. Which one do you think that is? Well, in this case, this was actually a tornado. One of the few cases of a well-defined funnel cloud. A little hard to see, especially because of the time of day. This was getting just past sunset, so talking about dusk time, and it's kind of hard to see also with the darkening of the skies with the storm. This was, as I mentioned, relatively recent. It was from a tornado outbreak in October of 2018. This was the largest single day of tornadoes in the month of October in Pennsylvania. Within our area, there were two, one in Carbon County and one in Monroe County. In this case, this was an individual who was up on an access road to a tower at the top of a hill. And I like to emphasize, no injuries in this case. He got off the mountain, which was good, because that tornado went through very close to where he had been and caused quite a bit of tree damage in the area. And they actually had to, that access road that you see there was not accessible for a good part of the day the next day on October 3rd, because they had they had to clear so many trees. It took several hours to make that road accessible again. So, back to our primary focus in staying safe. What are those safety rules when we're talking about tornadoes? With tornadoes, if you can remember, get in, get down, and cover up. What that means is get inside a sturdy, well-built building. I'm not talking about mobile homes, and we'll talk more about that in a minute. I'm not talking about vehicles. You need to be in a sturdy, well-built building. Get down means get to the lowest level available to you. If there's a basement, that's wonderful. Basements are great places. If you don't have a basement, if you are in a building that doesn't have a basement, or if you are in an apartment complex and the basement is not available to you, just get to the lowest floor that is available to you. And then when you get to that lowest floor available to you, aim to get to an interior room. So the goal is to put as many walls between you and the outside as possible, and of course avoid having any windows in the room that you shelter in. If you are at an office or in a public space, most of those areas should have a tornado safety plan. If it's your office building, you don't know what it is, it's a good idea to ask. And most shopping centers, airports, hotels should have it pretty well posted as to what the tornado safety plan is. As I mentioned, mobile homes are not safe during tornadoes. So if you live in a mobile home, have a safety plan. Know where you can find a storm shelter, or know what is the nearest sturdy building that you can take shelter in. Vehicles are not safe in tornadoes. The number one safety rule I can tell you is if you are traveling when a tornado warning is issued, do what you can to find a sturdy building to take shelter until the storm passes. So a little bit about the safety rules we have here in a real life example. You see a picture on the right hand side there of a house. And that is the before picture, and that is the after picture. Obviously, it was a pretty significant tornado that hit this house. But as you see, the lower floor is relatively untouched. There is obviously some minor damage, but the walls on the lower floor are for the most part standing. So that's why we tell you to go to the lowest floor available to you. And why we tell you to go to the interior room, as you can see up there on the second floor, if you couldn't get down to the lower floor, you can see there is an interior room where most of the walls are still standing. So that is why we tell you to go to the lowest floor available to you, and then go try to put as many walls between you and the outside as possible. Go over a little bit of some myths about tornadoes and straight line winds. One myth, only tornadoes sound like a freight train. That freight train noise, which is oftentimes associated with a tornado, that can also occur with strong straight line winds in addition to tornadoes. So that low howling sound, that can occur with multiple features. Skip past the second one because we'll talk more about how we assess damage here in a minute. But on to that third one. It's safe to seek shelter from a tornado below an underpass. There is a famous video from the 1990s. A TV crew was out on an interstate, I believe, when they had a tornado that was approaching them. And they sought shelter underneath a bridge in an underpass, along with several other motorists in the area. They were very lucky. There were no serious injuries, but that is not a safe place to seek shelter. And I think the reason this myth is so prevalent is because of that famous footage. Why it's not safe to seek shelter in an underpass is that, number one, you don't know the condition of the bridge. You don't know how structurally sound it is. And number two, the wind from a tornado will need to go somewhere. And in the case of an underpass, it's going to kind of funnel it through that underpass. And so that funneling effect can actually make the wind stronger. Again, underpass, not a safe place to seek shelter. As I mentioned, we would be talking more about the process we use to survey after a storm has passed and the rating system that we have for tornadoes. So the rating system is called the Enhanced Fujita Rating Scale. It is named because the original rating system for tornadoes was done with some groundbreaking work by Dr. Ted Fujita. And so we had the Fujita scale for tornadoes up until the last decade. It was about 2007, 2008 that the Enhanced Fujita scale replaced the original one. And this rating scale, in addition to building on the work that Dr. Fujita did, Texas Tech also contributed a lot of research based on wind tunnels. And what we do is, because we don't have wind measuring equipment on every block, we rely on the damage that we observe after a tornado passes to get an estimate on the wind speed. This has all been done with case studies of previous tornadoes, as well as studies within controlled environments such as wind tunnels, to get these estimates. So as I mentioned kind of at the beginning of this discussion, the vast majority of what we see here in the Mid-Atlantic is on the lower end of the scale, the EF0 and EF1. EF2 and EF3 are less common, considered significant, and even though vast majority that we usually see are EF0 and EF1, as I'm recording this, in 2019 we have had 2 EF2 tornadoes in southeastern PA, so it's not unheard of to have the EF2s and EF3s, but they are much less common. EF4 and EF5 are, of course, the higher on the scale, much more significant damage. They are very rare, especially around here. Less than 1% of all tornadoes are in in these major categories. They tend to be a lot longer lived, and even though they are very rare, they account for a majority of tornado fatalities. So we'll just change directions here and talk about straight line winds. In our part of the country, in the mid-Atlantic, straight line winds can be just as dangerous, if not more dangerous, and often cause more damage than tornadoes in our area. So it's oftentimes kind of looked at as a lesser hazard compared to tornado, but especially in the mid-Atlantic and really anywhere, it should be treated with just as much respect as tornadoes. There's a couple different ways that we can see straight line wind, severe straight line winds. One is with downbursts. And subgroups of this include microbursts and macrobursts. It just has to do on what scale that occurs. But a brief explanation on what a downburst is we were talking earlier about the downdraft, and if the downdraft is strong enough, once that pocket of air or that parcel of air reaches the ground, it has to go somewhere, so it spreads out. And if it's strong enough, that spreading out process can produce some very strong winds. We're talking about wind speeds in excess of 100 miles per hour are possible with the strongest downbursts. As I mentioned before, they can do as much, if not more, damage than a tornado. In fact, we'll talk more about this in a minute, but a tornado's damage is typically along a rather narrow path, where in the case of downbursts, it usually occurs over a larger area. So it's quite common actually to see more damage just because of the area that is covered compared to a tornado. Generally, it's going to kind of bow out, or a lot of the debris is going to be laid over in one direction, typically when we're looking at downbursts. Not always, but typically. Here's a real life example. In this picture, you can kind of see that blob that's kind of just right of center in this picture. That is a downburst just about to happen. That blob is the downdraft that is approaching the ground, and again, as it gets to the ground, can't go any lower, so it has to just spread out. But downburst is just one thing. One way to get straight line winds. We can also get straight line winds from squall lines, and squall lines, or also sometimes called QLCS, quasi-linear convective systems, and that's just a fancy way to say storms that are oriented in a linear fashion. Of the squall line, there is a very specialized type of squall line called a derecho. And we've had a few in the recent memory. One, probably the biggest one and the most memorable, was from June of 2012. So a derecho is a especially widespread and long-lived squall line storm. Not all squall lines are derechos. Only a small percentage are. In the case of the 2012 derecho, this one actually had its origins. It's actually kind of off this chart, but it actually had its origins in Illinois, and progressed east through the afternoon and evening before finally moving offshore in our area and southeastern Virginia. You can see kind of a mosaic of radar imagery from that night in 2012. In this event, they can produce some tornadoes, but they're really more known for the straight line winds. And you can see all of those yellow boxes are severe thunderstorm warnings, whereas the red boxes, which there's only about 5 of them, I believe, are a tornado warning. So you can see tornadoes not as common, but again, they can produce just as much, if not more, damage as tornadoes. And here's another illustration of that. These are the reports that came in with that derecho. All of the blue, blue boxes are wind reports, and all of the black boxes are especially high wind reports. The red are tornado reports, and there's only 2 of those in this case. So now a little bit about assessing damage after a storm has moved through. Once a storm has moved through, our office will determine if we need to send out a storm survey team. And when we send out a storm survey team, we have 2 primary goals. Number 1, we're trying to determine if the damage that occurred was due to a tornado or due to straight line winds. One question I get when I bring this up is, will my insurance company care, depending on what you rate it, depending on what your determination is? And the answer is no. Insurance companies know that, as I have mentioned, straight line winds do just as much, if not more, damage than tornadoes. So that determination does not have an impact on insurance claims. The second goal, first goal determining if it was tornado or straight line winds. Second goal is getting an estimate of the maximum wind speeds. And again, we'll be using the enhanced Fujita scale in determining, based on the damage that we see, what the estimated wind speeds are. So this first example is damage from a tornado. One of the determining factors in this case is that you see several houses that have either minor damage or are almost untouched, almost right next to other houses that have a very severe damage. And that's pretty common with tornadoes. Again, they tend to produce damage on a rather narrow path. So if you look down here in the lower left-hand corner of this picture, you'll see one residence there that has significant damage, significant roof damage, and even some damage to exterior walls, sitting right beside another house with relatively minor damage. So again, that's typically a hallmark of tornadic damage. Here's an example. This one is straight line wind damage, and the determining factor here is you see how the debris in this case looks like it's all been pushed to one side. That is a indicator of straight line winds, and that instead of a tornado, which tends to throw debris in all different directions, this has all been thrown mostly in the same direction. Here's an example using tree damage. And the example on the left is tornadic, and that is actually from that October 2nd, 2018 case that I showed you a picture of earlier. This was in Carbon County, and it was interesting the origins of the tornado, and this is actually where the path of the tornado started. It was so remote, it was hard for us to get there by car, so our thanks to the Civil Air Patrol, they actually did a survey, aerial survey, so we could determine where it started. But you see there's significant tree damage. A lot of trees snapped or pushed over, but it's over a relatively narrow path. Compare that with the image on the right-hand side. This is of a hillside, and you can see most of the trees on this side of the hill have been pushed down, uprooted, or snapped. But another interesting factor is that they are all fanning out from a central location, and that is a sign of a downburst. So again, the picture on the right is a sign of straight line wind damage, likely downburst, and on the left is tornadic damage. Now we'll talk about hail. So how does hail form? Hail forms when liquid water is elevated above the melting layer or the freezing level, 32 degrees Fahrenheit, 0 degrees Celsius. And if it is lofted above that freezing level for long enough, obviously ice begins to form. It will go through a cycle where it gets caught in the downdraft and may fall. And then if the right conditions, it will get picked up by the updraft once again, and in that process, in that circle that it's making, it's going to be picking up more and more liquid water, and as it does that, it will continue to grow. Eventually, it's going to grow too large for the updraft to continue to loft it in the cloud, and so it will fall to the earth. As I mentioned earlier, what we consider to be severe is 1 inch in diameter or larger. So in terms of coin, that is the size of a quarter or larger. Again, it's in a cycle where it forms in the updraft and just kind of makes a loop until it gets to be too large for the updraft to keep it aloft. The size that hail will fall back to earth is dependent on the speed that hail will fall back to earth is dependent on the size of the hail. So the larger the hail, the faster it will fall. And by the time you get to baseball size, which fortunately around here, of course, is a very, very rare occurrence, but by the time you get to baseball size, that hail can fall at speeds greater than 100 miles per hour. So if you can think of essentially a major league fastball pitch made of ice. That's the best analogy I can give. Obviously, you do not want to be caught outside when hail is falling, because it will hurt quite a bit. The big thing with hail is that it causes considerable property and crop damage every year. On average, it causes over $1 billion all total in damage to property and, of course, crops, especially given the high plains where it is most common. Being a large agriculture area, it causes considerable damage to agriculture every year. Here is how we reference hail. You can see on left-hand side there the size, and on the right-hand side what we typically reference it to. One thing you'll notice on the right-hand side is that you do not see any mention of marble. And the reason for that is that marbles come in all sorts of different sizes. So if you're giving a report of hail and you report marble-sized hail, don't be surprised if we come back and ask you to relate that to the size of a coin. So in the case of hail, typically rule of thumb is to relate it to a size of a coin until it gets too big, and then we'll ask you to relate it to, reference it to sports. So go through all the coins: penny, nickel, quarter, any one that's not listed there, dime, $50. Once you get above $50 size, golf ball, tennis ball, ping pong ball, whatever the case may be. When it comes to hail, pictures are fantastic, and even better yet is when you can put in a reference point, as in the case of these two pictures, with the hail. All right, so we're going to pause here for a minute and talking about the different types of severe weather and how to stay safe, because I want to talk a little bit about locally what a crazy year this has been. We've had a lot of interest in the Skywarn program this year, and I think a lot of it has to do with the weather that we have had this year. The bottom line is, if it seems like you've been getting a lot more weather alerts on your phone, it's true. We have had a very active year, severe weather-wise. We have had, just with severe wind, hail, or tornado reports, over 1,100 reports within the area that our office covers. Our office has issued 410 severe thunderstorm warnings this year, in the calendar year 2019. The previous record of severe thunderstorm warnings in a single calendar year was 307 back in 2011. So we have far exceeded the previous record. Also, interestingly, that is, of all the National Weather Service offices in the country, that is the 6th highest total. And what's interesting about that is, if you see that list of offices that have issued more severe thunderstorm warnings than us, it's not surprising that most of those are out on the high plains, with the exception of our sister office in Northern Virginia. So it's pretty unusual for the Mid-Atlantic to have as active a severe weather season as the high plains. So it's been a very unusual year in our area. We've issued 32 tornado warnings. As with the severe thunderstorm warnings, this is a new record high number of tornado warnings that have been issued in a single year. Previous record was 29 in 2011. And what's interesting about that too is that in 2011 we had the remnants of a tropical system, which is not uncommon when we have a large number of tornado warnings, because with tropical systems they can spawn tornadoes, especially in the right front quadrant of a tropical system. But in the case of 2019, this year, we haven't really had any tropical systems. So a lot of this has just come with other forms of severe thunderstorms. Though we have issued 32 tornado warnings, of the tornadoes that have occurred, we have had, again, as of the recording of this in early November, 14 tornadoes. And you can see the breakdown there. Issued 86 flash flood warnings. That is higher than most years, but still not as high as what we saw last year, 2018. 113 flash flood warnings were issued last year. That is the record for our office. Last year was interesting that we had a very active hydro year, active flooding, flash flooding, etc., but relatively quiet in the severe terms. We actually issued more flash flood warnings last year than we did severe thunderstorm warnings last year, which is very unusual for our office.